are the most popular methods used to produce hollow products out of thermoplastic materials. Blow molding evolved from the ancient art of glass blowing. Today, it is a leading plastic manufacturing process because of the wide range of plastic resins that can be blow molded and the many possible methods of blow molding. Blow molded parts range in size from the very small to extremely large parts. Bottles and containers are the most common blow molded products, but other items such as highway barrels, automotive components, double-walled cases, toys, medical items, and structural panels are produced. Blow molded products are formed from thermoplastic resins such as high-density polyethylene, medium and low-density polyethylene, polyethylene terephthalate, polypropylene, polyvinyl chloride, thermoplastic elastomers, polystyrene, polycarbonate, fluoropolymers, polyimide, and many other materials. Most thermoplastic blow molded products are produced via extrusion blow molding using high-density polyethylene or HDPE. But there are many additional blow molding processes which include injection blow molding, biaxial stretch blow molding, and co-extrusion blow molding. These blow molding processes all use elements of either extrusion or injection molding, or a combination of the two. In addition, these blow molding processes all share 4 common stages: plasticizing or melting the resin, parison production when referring to most blow molding operations, or preform production when referring to biaxial stretch blow molding, parison or preform inflation and cooling in the blow mold, and ejection from the blow mold. A 5th stage is necessary in extrusion blow molding for trimming and finishing the product. For the most part, blow molding processes all use the same blowing technique, whether it be through a blow pin, a needle, a stuffer, or core rod. It is in the production of the parison or the preform where these processes differ. The process of extrusion blow molding involves applying heat and pressure to thermoplastic resin to produce what is called the melt. This melt is then forced through a die to produce a parison, which is then dropped, trapped, or conveyed to an open blow mold for subsequent blow molding. Extrusion blow molding uses either an intermittent or continuous method for the formation of the molten parison. Intermittent extrusion produces a parison only when the blow mold is ready. These parisons are produced by using either a reciprocating screw or an accumulator and ram style machine. The main sections of a reciprocal screw extrusion blow molding machine are the hopper, an externally heated feed barrel, a reciprocal screw which has a feed zone, compression zone, and metering zone, and the head and die assembly. Resin, usually in the form of plastic pellets, is fed to the feed barrel from the hopper. This hopper may be filled manually or vacuum fed automatically. As the resin enters the feed barrel, it is driven forward by the rotation of the screw. The resin begins to melt as it is moved forward due to both the frictional shearing forces generated by the rotation of the screw and the heat from external heating bands attached to the feed barrel. The melted resin builds up in pressure as it is compressed and confined at the end of the feed barrel. To control this pressure buildup, the rotating screw is retracted. Once the proper amount of melted resin is available, the screw is hydraulically forced forward. This rapidly forces the homogeneous melt through the extruder's head and die assembly to form a parison. In the accumulator type of reciprocal machine, a reciprocal screw forces melted resin into an accumulator. The accumulator is a reservoir that holds the melt under pressure and temperature, while maintaining the specified amount of homogeneous melted resin required to produce the Parison. Once the accumulator is filled to its desired position, a hydraulically operated ram forces the homogeneous melt through the head and die to form a Parison. Using an accumulator makes the delivery rate of the melt that forms the Parison independent of the delivery rate of the extruder, and provides for the formation of large Parisons at a very fast rate, so Parison sag doesn't become a problem. An accumulator is typically used to manufacture high production, large industrial parts, and may hold up to 54 kilograms of resin to produce the Parison for a single part. Continuous extrusion produces an endless Parison, which is constantly positioned in blow molds for processing. The main sections of a continuous blow molding extrusion machine are very much like the reciprocal screw machine, except that the screw continually rotates, but does not reciprocate. This constantly forces melted resin from the front of the screw through the head and die to form a continuous flowing Parison. Both intermittent and continuous extrusion have head and die assemblies whose functions are to form the melted resin into a uniform Parison and to maintain a constant temperature and pressure on the melt while providing the desired wall thickness as the melt exits the die as a Parison. Most extruder head and die assemblies are classified as the crosshead type, which diverts the melt flow 90 degrees from a horizontal to a vertical orientation. Two kinds of crosshead die assemblies are most commonly used in extrusion blow molding: the center feed and the side feed assembly. The center feed assembly produces a fairly uniform melt by forcing it to flow vertically downward around the tip of a conical torpedo-shaped core called a mandrel or pin. This results in straight flow all around the mandrel. In the side feed assembly, the melted resin is forced around the perimeter of the mandrel, allowing the melt to flow uniformly down around the mandrel and then extruded through the die as a Parison. The die consists of a mandrel and a bushing, which are designed to produce a Parison of the desired wall thickness. There are two primary types of die tooling: converging, which flares inward, and diverging, which flares outward. As the hot Parison is extruded to its desired length, it is subject to sagging, which causes thinning at the top of the Parison. To overcome this problem, it's best to extrude the Parison as fast as possible at the correct temperature while using a Parison programmer. The Parison programmer's function is to move the mandrel, increasing or decreasing the gap between it and the bushing. This varies the Parison's wall thickness as it is being formed. Most intermittent and continuous extrusion machines utilize some type of Parison programmer. Intermittent extrusion is used on a variety of blow molding machines to produce a wide range of products. Continuous extrusion utilizes several processing techniques on many different blow molding systems. These include shuttle or reciprocating blow molding systems and rotary wheel blow molding systems. Shuttle or reciprocating blow molding frequently uses multiple molds, thus requiring multiple Parisons. This is achieved by use of a manifold, which distributes the melted resin to several dies for formation of the Parisons. Usually, a cutting device is mounted below the die head or die heads to cut the Parison or Parisons. Once the molds arrive at the blow position, a blow pin inserted into the mold or a needle integral with the mold enters the Parison and blows the product into shape. For larger, long-run, high-production parts, up to 20 or more split molds can be mounted on either a horizontal turntable or vertical rotary wheel for continuous blow molding operation. As the rotary wheel turns, molds pass under the extrusion die to receive and close around the Parison. Blowing air is introduced through a blowing pin, which penetrates the parison as the mold closes. As the wheel rotates, the molds can be either opened or closed via cams or cylinders. The speed or revolution of the wheel determines blow time, cooling time, exhaust time, and eject time. Once the wheel rotates to a specific position, the blow mold opens and the product is ejected and trimmed.